In this video, we're going to have a look at indices and the first three index laws. Powers. The product of repeated factors can be written using powers. For example, 2 times 2 times 2 times 2 can be written as 2 to the power of 4. The small 4 is called the index or exponent. The plural of index is indices. The 2 at the bottom is called the base. And the whole expression, 2 to the 4th or 2 to the power of 4, is known as the power. We can therefore write a rule: any number to the power of m, a times a times a times a times a with m factors of a, can be written expanded notation to index form. Any number without an index shown has a power of 1. That is, any number, let's say a, written without a power is to the power of 1. But we don't normally write the index of 1. Index laws are rules, or what I like to think of as shortcuts, for simplifying expressions involving powers of the same base. The first index law is known as multiplying powers of the same base. Let's take the example 5 to the power of 2, or 5 squared, times 5 to the power of 4. Writing it in expanded form, 5 squared is 5 times 5, multiplying by 5 to the power of 4. You can see there are 6 5's multiplied together. That is 5 to the power of 6. Notice if we add the two indices, that is 2 plus 4, we get the result. So we can use this rule rather than expanding. For instance, 8 to the power of 3 times 8 to the power of 4. We know when we're multiplying indices with the same base, we can simply add the powers. That is 8 to the power of 3 plus 4, which is 8 to the power of 7. So when multiplying numbers with powers and the same base, you can simply add the indices. We can write this as a rule: any number to the power of m times the same base number to the power of n, we can simply add the indices. This is known as the first index law. Note, if the bases aren't the same though, the rule will not hold. So if this was 2 and this was 3, we can't use this rule. The second index law is known as dividing powers of the same base. Let's take the example 7 to the power of 5 divided by 7 to the power of 3. We can also write this as a fraction using a vinculum, 7 to the power of 5 over 7 to the power of 3. Now if we expanded this out, 7 times 7 times 7 times 7 times 7, all over 7 times 7 times 7, we can see we have some numbers to cancel. That is, the factor of one set of 7's can be cancelled, another set of 7's, and another set of 7's, leaving 7 times 7, which can be written in index form as 7 to the power of 2. Notice, if we subtract the two indices, we get the result. That is, we could write without expanding, for instance, 6 to the power of 7 divided by 6 to the power of 2, simply subtracting, we get 6 to the power of 5. So when dividing a number with powers of the same base, we can subtract the indices. this rule, a to the power of m divided by a to the power of n, or in fraction form, we subtract the powers. This is known as the second index law. The third index law is known as raising a power to a power. That is, if we had 4 to the power of 3 all to the power of 5. Well, this is like 4 to the power of 3 times 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 4 to the power of 3. That is, we've got 5 sets. Now, relying on what we did in our first index law, we can simply add the powers. 3, 6, 9, 12, 15. Notice here that it is the same as if we multiplied the powers. That is our rule. Any number to a power to another power, we simply can multiply the indices. In the second video, we'll introduce some more index laws.